Hi everyone, this is Krishna, chemistry faculty. Students, today I am going to discuss the question paper which was held on Jan 2025 24th shift 1. Let us see the question paper, students. Yes, the question number 1. For a reaction, N2O5 gas produces NO2 gas and oxygen gas upon its decomposition in a constant volume container. No products were present initially. What is the final pressure of the system when 50% of the reaction gets completed? So, how to calculate the final pressure of the system? See here, N2O5 gas gives NO2 gas and oxygen gas. Here, let us see the initial pressure as P naught. After a 50% or after a time t, the pressure may be P naught minus x and 2x and x by 2. Now, 50% of reaction completed. What is the final pressure is going to ask. Therefore, x should be P naught by 2. Now, pressure P is equal to P naught minus P naught by 2 plus of 2 into P naught by 2 plus P naught by 4 is the total pressure after 50% of the reaction completed. Then after then P is equal to 7 by 4 P naught. That means the total pressure of the system when 50% of the reaction gets completed is 7 by 4 times of its initial pressure. So, option 1 should be the correct for the given question. Now, let us go for the next question, students. Yes, that is statement based question. Here, statement 1 given as Dumas method is used for the estimation of nitrogen in an organic compound. Yes, Dumas method is used to estimate the nitrogen. And statement 2 is Dumas method involves the formation of ammonium sulfate by heating the organic compound with a constant H2SO4. No, students, in Dumas method, the nitrogen present in the organic compound converted into what is that? Nitrogen, molecular nitrogen, but he said ammonium sulfate. So, statement 2 should be false and statement 1 only correct. So, the option is 1. Statement 1 is true, statement 2 is false. Next, go for the next question, student. The large difference between the melting and boiling point of oxygen and sulfur may be explained on the basis of. Generally, oxygen as O2 is present and sulfur is present as S8. That is, oxygen is a diatomic, sulfur is a octatomic. There is a large difference was occurred between the oxygen and sulfur in their melting and boiling points. Actually, these melting points are boiling points. Generally depends upon intermolecular force. These intermolecular force again depends, intermolecular force here majorly is van der Waals force. This again depends upon size and mass of the species. Here the sulfur is octatomic, large atomic mass as well as large size when compared to oxygen. Therefore, the atomicity is the reason for their large difference in their melting and boiling point of oxygen and sulfur. So, option 2 should be the correct. Let us go for the next question, students. 1 mole of octahedral complex compound CONH3 taken 5Cl3 gives 3 moles of ion on dissolution in water. Statement 1. 1 mole of the same complex reacts with excess of AgNO3 solution to yield 2 moles of AgCl. These are the two clues. That is, complex when dissolved in water given 3 ions, when they dissolved in or reaction with AgNO3 given 1 mole of the complex was given, what is that? 2 moles of AgCl. Here that means 3 ions is one should be the complex ion, other should be the two chloride ions. 2 moles of AgCl to be precipitate, therefore the complex should have 2 chlorines outside, and it is a octahedral complex. The total number of ligands, because all are given as monodentate ligand, the coordination number should be 6. So better option is fourth option, because complex is 1 ion and ionizing sphere as 2 chlorine. After this complex 4, when dissolves in water, gives 3 moles of ion from 1 mole of the complex. When treated with AgNO3 also gives 2 moles of AgCl, because the 2 chloride ions are only present in one complex in ionizing sphere. So, and we cannot go for the option 2 since the coordination number is 5. It is also makes us in confusion, and another is looking 6 here, but 1 chlorine is only outside. So option 4 is the best option for the given question. Now go for the next question, students. Yes, the next question is on molecular orbital theory. Which of the following linear combination of atomic orbital will lead to formation of molecular orbital in homonuclear diatomic molecule? Here the given is internuclear axis is z direction. You know everybody, students, the linear combination of atomic orbital, there are some conditions. What are the first one? The combining atomic orbitals should have the same or nearly same energy. Same or nearly same energy. The second condition is combining atomic orbitals should be symmetric with respect to molecular axis, or having same symmetry with respect to molecular axis. And number 3, the combining atomic orbitals also should have maximum or greater extent of overlap. These are the 3 conditions for the linear combination of atomic orbitals. Here majorly in option A, 2pz and 2px, that is the orbital is z, let us say as x. Now this have no, what is that, same symmetry, so option will be A will not be possible. If you go for the option 2, students, in option 2, 2s orbital, they given that, let us say as this is x and this is y. Now this is the x 2px orbital, let us see, but the molecular axis is given is z. That means this is also does not possible to undergo combination. And if you go for the C also, 3D xy, here the lobes are present between the axes. If you go for the next one, 3D x square y square, that is lobes are present on the axis, it also does not what is it, favorable for combination. And 2s and 2pz, yes, it may be the chance. You see the students, 2s, let us consider this as a z axis and this as x axis, and the perpendicular one should be the y axis. Now 2pz, yes, 2pz, let us say as z axis and x axis. Yes, this 2s and 2pz have the chance to get the overlapping or intermix, what is that, combining capacity. And again the E, 2pz and 3D x square y square, yes, likely this is the 2pz. Now this is x and 3D x square y square, again this also, this electron density in the xy plane. For the 2pz, the electron density on the z direction, again they have no same symmetry to combine. So among the given, only option D is the favorable condition for the linear combination of atomic orbital to give molecular orbital. So option should be the 2 is correct. Okay, now students, now let us go for the next. So there are 4 molecules P, Q, R and S. Which one of the following 4 molecule will react with HBr in the fastest rate? Here the given all the 4 molecules are, that is alkenes. So addition of HBr to the alkene is a electrophilic addition reaction. After addition of what is that electrophile, carbocation is generated. Okay, this step is the rate determining step. As the stable carbocation is generated, the reaction rate will be more faster. So generation of carbocation will decides, or stability of carbocation will decides the what is that rate of reaction in these 4 molecules. So among these 4, that second option Q, after attack of H plus or electrophile, generates stablest carbocation due to adjacent heteroatom with lone pair, which causes what is that back donation and what is the stabilizes the carbocation. Remaining P, yes, the carbocation is destabilized by minus I effect. In R, the carbocation generates stable, but it is stabilized only by plus inductive effect and hyperconjugations, and S also be the same. In Q only, the carbocation generated is the most stable one. So the Q will give the fastest rate of the reaction. So the Q containing option is 1. Therefore the answer is 1. Now let us go for the next question, students. This is also again organic chemistry question. Here a man has been asked to synthesize to the molecule X. Here the molecule went to in the next slide, I think so. You see this one, that is yes, this is the molecule X we are going to prepare. He thought of preparing the molecule using an aldol condensation reaction. He found a few cyclic alkene in his laboratory. He thought of performing ozonolysis reaction on alkene to produce a dicarbonyl compound, followed by aldol reaction to prepare X. Now predict the suitable alkene that can lead to the formation of X. So first he wanted to apply ozonolysis followed by aldol condensation. So among the given, option 2 is the better one. Let us see. First, upon ozonolysis, here we are doing reductive ozonolysis. Then we are getting yes, this is the compound intermediate carbonyl compound first, which on aldol condensation. Which on aldol condensation. What is the aldol condensation? The carbonyl reacts or condense with the alpha hydrogen of the another carbonyl. Here aldehydes are more reactive than ketones in the condensation. So here the possibility is this, that is 1, okay, 2, 3, 4, 5, 5-membered ring, and gives this as the product. So for the given question, the suitable answer is 2. Now let us go for the next question. Ksp of chromium hydroxide is 1.6 into 10 power minus 30. What is the molar solubility of this salt in water? S. Generally Ksp is equal to x power x, y power y, s power of x plus y for a salt Ax and By. For the given salt chromium hydroxide, that is x is equal to 1 and the y is equal to 3, then Ksp is equal to 1 power 1, 3 power 3, s power of 1 plus 3. Already Ksp given as 1.6 into 10 power minus 30, which is equal to 27 s power 4, then s is equal to 1.6 into 10 power minus 30 by 27 whole power 1 by 4. So, the option is 3. Okay, now go for the next question. Yes, again the question is from biomolecules. The carbohydrate ribose present in DNA is, actually in DNA the ribose present is beta 2 deoxy. What is that? Ribose. Beta 2 deoxy D-ribose is the ribose present in the DNA generally. So, actually the structure of the compound is, yes, 1, 2, 3, 4, 5. Yes, it is a pentose. It is a pentose sugar present in pyranose form. No, it is present in the furanose form. And it is a D configuration. Yes, it is a D-ribose. In the open chain, we are writing this as, yes, it is a D-ribose or D configuration and is a reducing sugar when it is in free. Yes, because of having anomeric OH, it is easily reduces the either aldo, what is that, Tollens test, failing test. And is alpha anomeric form? No, it is a beta form. So, the options given are A, C, D only correct for the question. So, option 1 is the correct one. Now, go for the next question. Yes, this question is again from chemical bonding chapter. Which of the following statement is true with respect to water, ammonia and CH4? See, the central atom of all these molecules are sp3 hybridizer. Yes, water, ammonia, CH4 all are sp3 hybridizer. Therefore, A is the correct one. Water, ammonia and what is that, methane, HNH, HOH, HCH bond angles in water is 104.5 degrees, 17.5 degrees, 109.5 degrees. Yes, students, as the number of lone pair increasing, bond angle what happened? Decreases. Yes, methane has 109.5 degrees bond angle, ammonia has 107.5 degrees bond angle and water has 104.5 degrees bond angle is also the correct statement. The increasing order of dipole moment in the methane, ammonia and water. Yes, water has 1.87, ammonia has 1.45 and methane has 0 dB is the dipole momentum. So, the given again is the correct one. Both water and ammonia are Lewis acids. Wrong. Because of having lone pair with octet configuration, they act as a Lewis base, not as a Lewis acids. So, the statement D should be the wrong. A solution of ammonia in water is basic, correct? But in this reaction, ammonia and water act as a Lowry Bronsted acid and base respectively. I think this is the wrong answer. In ammonia and water, water protonates to ammonia or donates H plus to ammonia. According to Bronsted-Lowry theory, which donates H plus is the acid and which takes or accepts the H plus from the donor act as a base. So, ammonia should act as a base and water should act as a acid according to Bronsted-Lowry theory. So, the option E is going to be wrong. So, answer is A, B, C only. So, the A, B, C only containing option is 1. So, the last statement I think it was taken from ionic equilibrium. Now, let us go for the next point, next question. Which of the following arrangement with respect to their reactivity in nucleophilic addition reaction is correct? This question is from carbonyl compounds organic chemistry. Here nucleophilic addition reaction majorly depends upon two factors. One is steric crowding. This is nucleophilic addition majorly depends upon steric crowding as well as electron withdrawing groups. Yes, as the steric crowding increasing, nucleophilic addition reaction decreases. If they have same steric crowding as the withdrawing group increasing, nucleophilic addition increases. Since the withdrawing group creates more positive charge at the carbonyl carbon, which in turn causes more easily attack of nucleophile. So among them is stophenone, para-tolualdehyde, benzaldehyde, para-nitrobenzaldehyde. Yes, tolualdehyde, benzaldehyde, para-nitrobenzaldehyde, all of them aldehyde is present, but in stophenone only ketone is present. So ketone should be the lowest or small slowest in the rate. Among the aldehydes, this is minus M group, this is plus I and plus M like due to hyperconjugation, which increases the electron density, which withdraws the electron density. Therefore, the better answer for the given is option 3. Since para-nitrobenzaldehyde withdrawing group and there is no withdrawing or donating, but your donating group is there. So the answer is 3. Next, go for the next one, student. 62. Consider the given plots of vapor pressure versus temperature. Which amongst the following option is correct? Graphical representation showing depression freezing point of the solvent in a solution. So already we know that, student, solution have lower freezing point when compared to the solvents. Since as the addition of non-volatile solute, the vapor pressure decreases. See, the temperature at which the vapor pressure of the solvent or solution equal to vapor pressure of the solvent, the temperature you call it as a freezing point. Here see, in the graph 1 solution line is upper, in graph 2 solution line is upper, in graph 4 also solution line is only upper. Generally the solution vapor pressures are lesser than the top solvent. That is also one clue. Here you see, this is the freezing point of the solvent and the freezing point of the solution. Yes, this graph should be the correct. Since as the addition of solute, vapor pressure decreases. According to the definition of melting point, the liquid solvent has more freezing point than the solution. Therefore option 3 should be the correct for the question 62. Now go for the next question. Yes, which of the following ion is the strongest oxidizing agent? Yes, all the given ions are inner transition metals. In the inner transition metal, +2 oxidation state readily tends to +3, while +4 oxidation state changes to +3 and act as a oxidizing agent, and +2 act as a reducing agent. Therefore in the given option, +4 terbium is the oxidizing agent. Now go for the next question, student. The product A formed in the following reaction sequence is, here the given is the propine. Upon addition, that is Hg plus 2 H2SO4 means that addition of water Addition of water follows again Markovnikov rule. So OH adds at more substituted carbon. After that gets tautomerizes and produces acetone. Yes. After that addition of HCN which produces cyanohydrin, which on reduction that cyanide become CH2 NH2. This should be the answer. Okay, the possible answer is 2. Now go for the next question. Preparation of potassium permanganate from MnO2, okay, involves two-step process in which the first step in the reaction with KOH or KNO3 to produce, yes, pyrolusite or MnO2 on alkali refluxation in the presence of air. First it produces K2MnO4 potassium manganate. After then it gets oxidized into KMnO4 either by electrolysis, some other process. But here the step 1 production of K2MnO4 occur. So option 4 is the correct for the given question. Now go for the next question. Which of the following statements are not true about the periodic table? Yes, the properties of the elements are functions of atomic weights. Here the periodic table is nothing but modern periodic table. What is the modern periodic law? The properties of the elements are the function of atomic numbers, not the atomic weights. So atomic number is correct, atomic weight is the wrong. Elements having similar outer electron configurations are arranged in same group, not in the same period. Therefore, again option C is not correct. An element location reflects the quantum numbers, okay, of the last filled orbital. Yes, element's location reflects the quantum number of the last filled orbital. According to that only, yes, 4s1 fourth period, 3s2 that is third, what is the third period. It will give the location of the s as well as their s orbital, that is L value, also decides the what is the position of the element in the periodic table. So the option D also be correct. The number of elements in a period is same as the number of atomic orbital available in energy level that is being filled. Yes, this is a wrong statement. In a period, the number of elements in a period is not as the number of atomic orbital available in energy levels that is being filled. Since let us see, okay, third period. The third period, the available orbitals are 3s, 3p as well as 3d. But in the third period, the electron filling only takes place in 3s, 3p, but not in the 3d na. So the option again is also wrong. So the wrong statements given in the question are A, C, E only. That is fourth option is correct. Now let us go for the next question, student. 67. Again the question is on statement based. The conversion proceeds well in the less polar medium. Yes, N-butyl chloride on alkali or OH minus produces N-butyl alcohol. Therefore, it is a nucleophilic substitution. We can say this is a SN2 mechanism since it is a primary alkyl halide, as well as the nucleophile also strong nucleophile. The conversion proceeds, second statement, the conversion proceeds well in more polar medium. Again, yes, it is also a primary alkyl halide, produces again a nucleophilic substitution. It is also be SN2. Yes, both are SN2 mechanism, but in the first one less polar, in the second one is more polar mediums are required, they said. What is the reason? You see here N-butyl chloride plus OH minus. Here the reactants are, what is that? Higher charged. are highly charged. In the transition state, is less charge density is present. High charge density in the reactants, and transition state has less charge density when compared to the reactants. Therefore, in the first reaction, if the medium is a less polar medium, which will not affect the activation energy of the reaction, since so that less polar medium favors or increases the rate of reaction for the first reaction. If you go for the second reaction, that is again N-butyl chloride, when treated with a triethyl amine, here the reactants are less charge density, in the transition state. Here transition state has more charge density or high charge density is present. So that is more polar medium will makes the reaction more faster by decreasing the activation energy of the reaction. Therefore, for the first reaction, the reactants are highly charged, but the transition state is a less charge density, so less polar medium. In the second reaction, reactants are less charge density is present, but in the transition state, high charge density is present. More polar medium makes it into less activation energy reaction, and in first reaction, less polar medium will makes into or does not increase the activation energy. So in first one less polar medium and second one more polar medium makes the reaction in fastest rate. So both statement 1 and statement 2 are correct for the given questions. Now go for the next question. Yes, the question is from electrochemistry. Now see, Fe plus 2 plus Ag plus aqueous gives Fe plus 3 aqueous and Ag plus Ag solid, the standard cell potential of the above reaction. Now for this one, that is E naught cell is equal to E naught of Ag plus 2 Ag plus E naught of Fe plus 2 to Fe plus 3. So we should have standard reduction potential of Ag and standard oxidation potential for the Fe plus 2 to Fe plus 3 we should required. But here Ag plus 2 to Ag was given, but Fe plus 2 to Fe plus 3 not there in the given statements. So first of all we have to find out this one now. Let us see here iron become Fe plus 2 and it will become Fe plus 3. Here say this is delta Z naught 1, let us say as delta Z naught 2, this as delta Z naught 3. We know the free energy change in the overall reaction is equal to free energy change in the individual step sum. So delta Z naught 3, Fe to Fe plus 3, they given as Fe plus 3 to Fe as Z, that is minus 3 F minus Z volts is equal to delta Z naught 1, Fe to Fe plus 2, yes, again given as the reduction potential was given as Y. So that is minus 2 F and minus Y plus of delta Z naught 2. Yes, since the Fe plus 2 to Fe, Fe plus 3 to Fe are the reduction potential, here we wrote as a oxidation, that's why I changed the sign. You see this is a 3FZ. This is 2FY plus delta Z naught 2, since delta Z naught is equal to minus NFE naught. So, delta Z naught 2 is equal to, delta Z naught 2 is nothing but Fe plus 2 to Fe plus 3 free energy change, that is minus 1 F, okay, what is that? E naught, we don't know that na, we don't know that E naught is equal to, what is that nana? Delta Z naught, that is 3FZ minus of 2FY, that is F gets cancelled, that is E naught is equal to 2Y minus of 3Z for Fe plus 2 plus 3, Fe plus 2 Fe plus 3. So, I got finally 2Y plus what is the 2Y minus 3Z as Fe plus 2 to Fe plus 3. Already they given E naught cell is equal to Az plus 2 to Az is x volts plus, now Fe plus 2 to Fe plus 3 I got 2Y minus of 3Z. So, the overall cell potential is equal to x plus 2y minus 3z, which was in second option. So, option 2 should be the correct. Now, go for the next question. Which of the following carbocation from the following is most stable? The carbocation stability generally increased by electron donating groups, or the groups are the surrounding which decreases the charge will stabilizes the carbocation. So, in the given options, the better option is what is that? Option 4. Since in option 4, after rearrangement, the carbocation produced is this, which is stabilized by what is that? Strong plus M group, OCH3. And this is also stabilized by resonance also na. Resonance as well as plus M effect both stabilizes the carbocation. But here this 3 also, that is carbocation adjacent with what is that heteroatom with lone pair is there, it is not a strong plus M group. Here in first option, after rearrangement, the carbocation stabilized by only hyperconjugation as well as only what is that? Resonance, but not by OCH3. That OCH3 causes here minus I effect. So, in the fourth option, after rearrangement, the carbocation is stabilized by what is that? OCH3 plus M effect. Therefore, the better option is 4. Now, go for the next question. Let us consider the endothermic reaction, which is non-spontaneous at freezing point of the water. However, the reaction is spontaneous at a boiling point of the water. Choose the correct one. You see, delta Z is negative is spontaneous, delta Z positive non-spontaneous. Here, according to the given condition, at freezing point, the reaction was non-spontaneous. That means at low temperature, non-spontaneous. At high temperature, it is spontaneous. That is delta G is equal to delta H minus T delta S. At high temperature spontaneous, mean the right value is more negative rather than the delta enthalpy change. To be occur mean delta H should be positive, delta S also be positive. Then only at a high temperature delta Z become negative. At low temperature delta Z become positive. So, the condition is satisfied only at both delta H and delta S are positive for the given question. So, now go for the next question. Consider the following reaction occurring in the blast furnace. Here, x kg of iron is produced when 2.32 into 10 to the power of 3 kg iron Fe3O4 and 2.8 into 10 to the power of 2 kg CO are brought together in the furnace. The value of x Here the question completely based on stoichiometric relation. Okay, now Fe3O4 plus 4CO gives rise 3Fe plus of 4CO2. Now let us see the number of moles of Fe3O4 given is how many? That is 2.32 into 10 to the power of 3 into 10 to the power of 3, because given in kgs, by 232, since the atomic weight, molecular weight of Fe3O4 is 232, that is 10,000 moles are given. The number of moles of carbon monoxide again given is 2.8 into 10 to the power of 2, again kgs are given, by 28, carbon 14, oxygen is 16. So the molecular weight is 28. Again the total number of particles or the moles are given are 10,000. But according to the stoichiometric equation, 1 mole of Fe3O4 requires 4 moles of CO. Therefore, the number of moles of CO given is in lesser quantity. That means CO should be the limiting reagent for the given question. So 4 moles of CO will produces, what is that? 3 moles of iron. Now 10,000 moles or 10 power 4 CO will produces how many? That is 10 power 4 moles into 3 by 4 moles of iron. Number of moles of iron are 3 into 10 to the power of 4 by 4. But the question asked in, what is that, Nana? What is that? Kg. That means weight of iron. I am multiplying with 56. After doing so, that is in kgs is 420 kg. It should be the 420 kg is the answer. Now go for the next question. Yes, among the following cation, the number of cation which will give characteristic precipitate in their identification test with potassium ferrocyanide. This question was given from inorganic qualitative analysis from the different cation identifications. So potassium ferrocyanide will precipitate. Potassium ferrocyanide gives precipitates majorly with, according to NCERT lab manual, copper plus 2 as well as Fe plus 3 and again Zn plus 2. According to NCERT lab manual, the potassium ferrocyanide gives the characteristic precipitate only with copper plus 2, Fe plus 3 and Zn plus 2. But in some standard books, they may mentioned calcium plus 2 also. What is that? As precipitation. So the key may be 3 or 4. Now go for the next question, students. 37.8 grams of N2O5 was taken in a 1 liter reaction vessel and allowed to undergo the following reaction at 500 kelvins. The total pressure at equilibrium was found to be 18.65 bar. Then calculate Kp. Assume N2O5 to be ideally under this condition. Okay, let us go for the answer. N2O5 gives rise to N2O4 plus of O2. Let us see what is the initial pressure. PV is equal to nRT, because he said N2O5 is ideal. That means pressure, initial pressure equal to nRT by V. Number of moles given 37.8 by 108 into what is that? R 0.082 bar liter mole Kelvin into temperature was given as 500 Kelvin. 1 liter vessel. So pressure is equal to 14.35 bars. This is the initial pressure. Now, according to the given question, 2N2O5, 2N2O4 plus O2, all of them are gases. At time equal to 0, the initial pressure is 14.35. After a time of t, 14.35 minus 2p, here is the 2p. Now here it become p. So the total pressure at equilibrium, let us say equilibrium condition. Now at equilibrium pressure is equal to 14.35 plus p. Already in the given question they given as 18.65 is equal to 14.35 plus p. Therefore the initial, what is that, the pressure p is equal to 4.3. So after substituting the values, after substituting the things, pressure of N2O5 is equal to 14.35 minus 2 into 4.3, that is 5.7. And now pressure of N2O4 is equal to 2p, that is 8.6, and the pressure of O2 is equal to 4.3. Now Kp is equal to, that is pressure of N2O4 whole square and the pressure of oxygen by pressure of N2O5 whole square. After substituting the equilibrium pressures in the Kp equation, we are getting Kp is equal to 9. What is that? 9.619. I got the value 9.9. What is that? 619. But they asked the question into 10 power minus 2. Then Kp is equal to 962, because the removed value is, or leftover value is 9. The value become 962 into 10 power minus 2. So the answer should be 962. Now go for the next question. Yes, the standard entropies of X2, Y2 and XY5 are 70, 50 and 110 joules per Kelvin per mole respectively. The temperature in Kelvin at which the reaction is will be, what is that, will be at equilibrium is. Here we have to calculate temperature of the equilibrium. Now according to that, the change in entropy of the reaction is equal to, what is it? Entropy of the, standard entropy of the product minus half into entropy of the X2 plus 5/2 into entropy of the Y2, that is 110 minus half into 70 plus 5/2 into 50. That change in entropy I got is minus 50. Now the question is at equilibrium, then delta Z naught is equal to 0. Delta Z naught is equal to delta H naught minus T delta S naught. Here 0 is equal to minus 35 into 1000 joules, because the given is kilojoules, minus of T into minus 50. After doing so, I got T is equal to 700 kelvins. So for the equilibrium temperature should be 700 is the answer. Go for the next question, student. Yes, X gram of benzoic acid on reaction with aqueous sodium bicarbonate released CO2 that occupied 11.2 liter volume at STP. So benzoic acid on treating with sodium bicarbonate produces sodium benzoate plus of H2O plus CO2. Here 1 mole benzoic acid gives 1 mole CO2. That is, moles of benzoic acid is equal to moles of CO2 produced. The moles of CO2 produced is 11.2 by 22.4, that is 0.5 moles. That means it is also equal to number of moles of benzoic acid. So the question is asked in weight in grams. So weight of benzoic acid is equal to 0.5 into 122, that is 61 grams. So the weight of benzoic acid produced is 61 grams of the students. Therefore, the answer for the question is 61. Thank you very much, students.